Okay, so where we left off was pretty much on this slide, and that's actually a really good place to start. So let's get a couple of reminders for ourselves real quick. So this graph, the whole thing, shows two things. It shows the increase or decrease going across this way in RPMs, and I believe we decided that that stood for revolutions per minute because a car motor, its engine, spins around. There's parts of it that have to spin around, and the faster it spins or makes revolutions, then the greater the horsepower. So it measures revolutions going from 0 up to 8,000 revolutions per minute, and then vertically it measures horsepower, right? This side, this axis is the horsepower from 0 to 350. The idea being your engine, when it is revving, it literally represents, like if you're at 275 horsepower, it's the power of 275 horses. That's not literal, that's just sort of a term that they've used. Okay, now remember a couple other important things. Here's one. This is the y-axis, the guy that's going up and down vertically, and this is the x-axis going this way. And when I say axis, it's spelled A-X-I-S. Kind of like the imaginary axis that is punched through the middle of the earth. And the earth, if you were to take a pin and take a foam ball, that's the earth, and you take the pin and you put it right through the center, that's the axis, and the earth kind of spins around on that pin, and the pin is the axis. All right, so we're just going to look at one of these, because I believe most classes, or all the classes, went through this. So just a reminder, and I'm going to keep this here. This is the x-axis, and this is the y-axis. So, for example, just to check on this point, 6,300, and that's called a coordinate pair, and it's always going to be the x value, comma, y value. The x always comes first. If you're not sure in the future, just remember it's alphabetical. So first I go over on the x-axis. Here I am, and I'm looking for 6,000. So I go over to 6,000. Here's 6,000. So I go over from 0 to 6,000, and I'm going to go up the y-axis to 300. So this point right here is 6,300. That is the address of this point. So I can say that point, which is right there, it does fall on this graph, because this blue snake kind of shaped thing, that's the graph, right? And this point literally is on that line. It's on the graph, okay? All right, well, let's move to something new. So this graph right here, that's the blue line, it's the background, but the graph is the actual line, right? So it measures two things. It measures the speed in mph, or miles per hour, and it starts with 0 and it goes up to 60. And it also measures on the y-axis, it measures the fuel economy, mpg, miles per gallon. How many miles your car can drive on 1 gallon of gas, okay? And that goes from 0 to 30 vertically. And I'm going to label these, just to get used to it. That's the y, and this is the x-axis. And remember, the coordinate pair is always xy. All right, so it says the graph shows a relationship between the speed of a car in miles per hour and the car's fuel economy in miles per gallon. Name a point that falls on the graph. So all you have to do is, you can choose anywhere in this graph. There are literally billions upon trillions of points. I mean, you can get as small as you want. I'm going to choose one, and that one right there speaks to me because it's on an intersecting pair of lines. So that means you can't choose it when you do yours. So if I put a point here, tell you what, I'll go over, I'll make it a little more challenging for myself. I will go, let's go to this point right here. I'm going to choose that point. And now I have to figure out where that is, what the address of that point is. So first, because I know that the x value is first, I start at 0 on the x-axis, and I go to where this thing is about, okay? Now I'm going in intervals of, what is this, 5? because it's 0, 5, 10, 15, 20, and so on. So therefore, the last line, grid line that it passed was 60. Well, I know that this next line must be 65. Well, this point seems to be about halfway between 60 and 65. So I'm going to go ahead and call that 63. So the x value is about right there, and that's about 63. And the y value, now I have to go over here on the y, start at 0 and I go up. What do you figure? That is about, it's a little more than half. This looks to be a little more than halfway up. So it's about right there. And this is 20, 25, 30. So it's going by 5s as well. So this is 25. This is 30. The point is more than halfway. And halfway would be 27 and a half. So I'm going to call that 28. I think that's pretty safe to say that the y value will be 28. So this point is the name of it is 6328. Sometimes you'll see this. You'll say, oh, yeah, that's point x. Well, that's not a good example because that's the x value. You can say that's point A. Well, point A address is 6328. So go ahead and label another point that is not the point that I labeled. Go for it. Just go ahead and pause the video. All right, did you go ahead and label that? I think we probably talked about that for a minute or two in class. All right, let's go to another one. Now you have a table and a graph. All right, here's the table. And remember, the table is organized this way. This is the x value. This is the y value. This column is the x. This column is the y. This is the input. This is the output. Okay, so let's keep the y. Oh, no, I won't be able to read it. There we go. Landscape architect is designing a greenway. The design calls for 620 trees on every acre. Complete the table. Then graph the relationship between acres and trees. All right. So here on the graph, you're measuring, oh, they finally labeled it. See, you have x and y axis. Acres from 0 to, it looks to be 30, and number of trees from 0 to, let's see, every 4,000, 16,000. All right, so the first pair, 0 acres, 0 trees. 5 acres, 3,100 trees, which makes sense because they said that there's going to be 620 trees for every acre. Well, that means that you're going to take the acres and multiply it by 620, right? So 5 times 620 is 3,100. 10 times 620, or 10 multiplied 620, is 6,200. Now you have to go ahead and complete what is 15 times 620, what is 20 times 620, what is 25 times 620. And I believe I probably said that you could use a calculator for this, and afterwards go ahead and graph it. In other words, plot these points. I'll help with the first two. 0, 0. Well, 0, 0 is called the origin, and it is right there. And I'm going to label it, I'm going to call it 0, 0. So that's point 0, 0. All right? So that's done. The next one is 5, 3,100. Well, here's 5 on the x-axis. 3,100, we went up to 4,000 here, so it must be 2,000, 4,000, 6,000, 8,000. So it's 2,000. Every grid line, every increment, every interval is 2,000. So this is 2,000, and then this is 4,000. Well, in between 2,000 and 4,000, halfway is 3,000. So a smidge, just a tiny bit past halfway, must be 3,100. So I'm going to go ahead and put a point there just past 3,000, and it'll be 3,100. And I'll label that, what is it, 5, 3,100. Actually, you know what? I won't put that comma in there so I won't confuse myself. All right, the next one is 10 and 6,200. So that means I need to go over to the 10, and then I go up to 6,200. Well, here's 8,000. Here's 4,000. So halfway between 4 and 8 is 6. but this is 6,200. So it's a bit past the 6. Not too much, but it's a little bit past the 6. So I'm going to say that that point is probably, let's see, it's on the 10. That's 6,000. I'm going to say it's about there. And I'm going to label it, what is it, 10, 6,200. Now you go ahead and fill in the table and plot the last 3 points. Pause the video, please. Okay, so this table has to do with kapok trees or kapok trees. I'm not really sure. It's a tall rainforest tree. Assume that a kapok tree grows 12 feet each year. Wow, that's 1 foot per month. That's a lot. Complete the table and use the points to graph the growth of the kapok tree. All right. Now, here's the first 3, just like the last one. The increments, this is a little easier to deal with because the numbers aren't quite so large. You don't have thousands and hundreds. You have tens. Okay? So you can do whichever you want. If you want to plot the first 3 points first and then complete the table and plot those, go for it. I like to finish the table first and then plot all the points. So let's see. You go ahead and finish the table and then start plotting the points. Pause the video. Okay, so I have finished the table and I have graphed the points. So your graph should look something like mine, where it is ascending. That means not only are these values going up, but these values are going up, which gives you an ascending, like climbing up kind of a graph shape, right? And so the rule is, if you come back here, x to y, the rule is, what are we doing to x to get the output, the y? Well, this doesn't help us, 0, 0. So 1 gets 12, 2 gets 24, and 3 gets 36. I'm pretty sure you can figure it out. I'm taking the input, or the x, and I'm multiplying it by 12 to get the output, or the y. So write it as an equation. So it's going to be 12 times x equals y, or 12x equals y. So that's the equation that shows this table. Yes, we only went to year 5. Okay, last thing to do. Directions. Use the graph, this graph, and here it is. You can see it's much prettier. It's so much more straight than mine. I didn't draw a line through them. You don't have to. To predict how tall a kapok tree will be in year 8. Okay. I was curious about that. So let's see. These are the years. The x-axis measures the years, and the y-axis measures the height. So I think I already just thought of a strategy, but I'm not going to share it quite yet. In year 8. All right, so here's year 8. I want you to go ahead and pause the video and put the point for year 8. All right, did you plot the point? Okay, so what I did was I thought, all right, well, here's year 8, and this is the height. So I go up and I hit where the graph intersects year 8, right about here. I'm going to go ahead and say that that is, let's see, 60 to 90, 30 to 60. So in the in-betweens, each grid line is going up by 15, 60, 75, 90, 105. So this point falls a little less than halfway between 90 and 105. Well, halfway between 90 and 105 is 97.5. And this is a little less than that. So I'm going to go ahead and say 96, maybe 97, but I'll go with 96. So that point should be called point 8, because I go with the x value first, comma, and what did I say it was? 95? Is that what I said it was? 95, 96. I'll go with 95. So that is 895. So how tall will the kapok tree be in year 8? Approximately 95 feet tall. And that's it. You can go ahead and begin the assignment. Thanks for watching. Thanks for participating. Thanks for thinking.